Hello and welcome to exploring one more aspect of linear systems of equations and their applications. These kinds of problems that I'm going to look at next are distance, rate, time problems. So distance, rate, time problems. There is a basic relationship between these. Distance is equal to rate or speed times time. This is um, simple for us to understand. For example, let's say we're traveling at 70 miles per hour for 2 hours. How long will we go? How long will we travel? How far will we travel? How far will we travel? Okay, so distance, how far, is equal to the rate, which is our speed, 70 times 2. So we would have gone 140 miles. Here's another way to think about it. Let's say you're traveling from here to Buffalo. That's about 70 miles. And it takes you, example, so you're traveling from Rochester to Buffalo, right? And that's about 70 miles. And it takes you 1.5 hours. What is your average speed, right? So again, distance is equal to rate times time. This time we know the distance, which is 70. We don't know the rate, but we know time, 1.5. So we can find the rate by dividing 70 by 1.5. So distance equals rate times time, a very useful little formula to remember. Alright, with that said, let's take a look at this application problem. Joe tries to exercise every day. He walks at about 3 miles per hour and jogs at 5 miles per hour. Takes him 0.9 hours to travel a total of 3.5 miles. How long does he travel? How long does he walk? How long does he jog? So start with the question. We don't know two things. How long does he walk and how long does he jog? So these distance, rate, time problems can also be done with a table. So I'm going to again create a table. So on the table are the rows of the table are the activities he does. So he walks, and he jogs, and this is his total trip. And when we talk about walking and jogging, there is some times and speeds and so on involved. So for example, he walks at 3 miles per hour. Now that 3 is for walking, so I'm going to put the 3 there, and that's a speed. I'm going to label that column speed. And then the 5, when we come across that, we can put it right there because that's his jogging speed. So speeds under one column. If it takes him 0.9 hours to travel, okay, so now careful, it takes him 0.9 hours. That's a time, right? So time. So it takes him 0.9 hours to travel a total of 3.5 miles. So 3.5 is a distance. So careful on that, right? So there's two numbers there, they go in different places. You wouldn't put them in the same column because one is a time and the other one is a distance. And it's 0.9 hours for the total trip. So I wouldn't put it in walks or jogs, I'd put it in trip. So I'll put 0.9 right there, and I'll put 3.5 over here. That's also a total trip. And it says how long does he walk and how long does he jog. So we don't know the time for him, so this is time, how long, right? Time. So time for walking we don't know, so let's call that W. And time for jogging we don't know, so let's call that J. And so those two we don't know, but we do know that distance is equal to speed times time. So I can fill this spot here by saying that's 3W, and I can fill this in as saying 5J. And you can sort of look down the columns and get your equations, right? So we could say W plus J, time for walking, time for jogging, must equal 0.9. And the distance walked plus the distance jogged must equal 3.5, the total distance. Now if we solve this, we get our times. Again, I'm going to use the addition method. I'm going to multiply this first one here by negative 3, and so that takes me to negative 3W minus 3J, if I distribute here, equals to negative 2.7. Right, let me check that. Yep, 2.7. And then over here we have 3W plus 5J equals 3.5. If I add these, the W's cancel, and I get 2J is equal to 0.8. And I can get divided by 2, and I get J equals to 0.4. So now that I know J, I can find W. So W plus J is 0.9, J is 0.4, so minus 0.4, and W equals 0.5. Okay, alright, so what did we find? Don't forget to report your answers. So jogging time, 0.4 hours. Walking time, 0.5 hours.